Okay, and then the second rearrangement we consider is a pinnacle rearrangement. Also involve for the carbon that lack of electrons. Okay, actually it's a conversion of substitute 1,2-diol to ketone or aldehyde. Okay, actually it's the same concept with the previous rearrangements, rearrangements. First step to form a carbocation. Okay, but this one special because it's involve 1,2-diol. 1,2-diol refer to this group, this hydroxy group at adjacent carbon. That's why it's called 1,2-diol. Okay, added to ketone or aldehyde. Okay, based on the structure, actually based on the R. The R, for example, in this case, is a metal group. Okay, so we form ketone. You will form ketone. If we replace with a H, so we form aldehyde. We form aldehyde. Okay. Okay, for example, like in this one, okay, we change with the H. Okay, that's why we form aldehyde. We form aldehyde. Okay, so based on the starting material. Okay, in terms of mechanism. Okay, in terms of mechanism, if you look at the scheme, okay, so if you ask to give a mechanism, so first you must show the movement of electron. That's a mechanism. Okay, so you mean first step is a protonation. You need to show the movement of 2 electrons. Okay, to take a proton, to take the H plus. Okay, and then to form positive. Okay, and to remove water. Okay, loss of a water molecule. Okay, that's why this carbon is a positive. Okay, to form carbocation, and if you reform migrations. Okay, you form migration to these positions. It's 1, 2 positions. Okay. Okay, so if you want to show full movement of electron, it will be like this. Okay, because oxygen has a pair of electron. So the pair of electron can move. Okay, and then this group will be transferred or migrated. Okay, to this carbon. Okay, to form positive on oxygen, and deprotonation. Okay, deprotonation. So if you deprotonation, mean you need to show movement of electron. Okay, give both electron to oxygen. Okay, that's why you leave for the H plus, and it can be used again as a catalyst. So that's a nature of catalyst. Okay, so the final product will be ketone. Okay, so really for the pinnacle rearrangement, it's a regioselective. Regioselective means it depends on the, in this case, depend on the carbocation. Its major product is based on the most stable carbocation, and then the stable cation form is a superior. It means we form major product. It's major product. For example, like in this case, this is a first step. Okay, first step is a protonation. Yeah, it's a protonation. Okay, and then loss of water. Okay, to form it's a carbocation. Okay, and then movement of electrons. Okay, movement of electrons from oxygen, and one of the hydrogen will be migrated to this carbon. Okay, to form this ion. Okay, and then loss of proton, okay, to form the final product. So in this case, it's aldehyde. It's aldehyde. Okay, so for this particular compound, why the protonation occur at this hydroxy, not the another hydroxy? Okay, so this is the concept of carbocation, the stability of carbocation. Okay, because if in this case, yeah, you take the hydrogen, the H plus, the proton, okay, from this side, okay, and then loss of water to form carbocation. This carbocation is a benzylic carbocation. I mean, it's stabilized by the localization of benzene ring. Okay, that's why it prefer at this position, compare with at this position, because this position is a primary carbocation, which is very less stable compared with this benzylic carbocations. Okay, so that's the reasons. And these are selective. These are selective reactions. Okay, so we form aldehyde. Okay, so when it involve phenyl group, so the phenyl group we move first. We move first. So in this example, the first example, okay, the first example. So it means if we take hydrogen, okay, and then loss of water to form carbocation, okay, to form carbocation, okay, and then it's oxygen, okay, then the electron, okay, and then the migration occur for phenyl group, yeah, instead of hydrogen. Okay, instead of hydrogen, phenyl group is most first. Okay, that's how we get this ion. This ion mean this migration of a phenyl. Okay, it's not occur for the hydrogen. Okay, and then the final product will be aldehyde. Will be aldehyde. Okay, and then for the phenyl with electron donating group, okay, EDG, one that we already discussed before, EDG, electron donating group, we move first. Okay, so for example, like in this case, there are two products. One is a major, one is a minor product. So the major product actually the migration or the transfer group is involved with phenyl with EDG. So in this case, it's a methoxy. The methoxy. Okay, so the final product, okay, for the major product will be the movement of this methoxy benzene. This is methoxy benzene. Okay. I mean, this will be the major product. Okay, and then this will be the minor product. Okay. Okay, and then for this one, under nitrous acid, the amino alcohol rearrange also under pinacol, right? Rearrangement. Okay, it means the same concept, but for this case, it's not diol, okay, but it's a amino alcohol. It's an amino alcohol. Okay, and then the one that take the H plus, actually it's a N, from the amino group. Okay, from the amino group, and then you form loss of ammonia to form carbohydrate ion at these positions. Okay, at this position, and in this case, you form this product. Why is a 5 membrane? Okay, because you break this bond, okay, attached to this carbon. Okay, that's why you get this 5 memory. 5 memory. Okay, it's the same concept. Okay, different example. Okay, so the first step, we take the H and loss of NH3, okay, to form carbocation. So in this case, this carbocation. Okay, let me write it first. It's a CH2 plus. Okay, but in this case, the product has larger ring. It's a 6-member ring compared with 5 for the starting material. Okay, so the mechanism should be like this. You break this bond. Sorry, you break this bond and then attack to the carbon. The carbon to form 6 membrane. To form 6 membrane. And of course, loss of proton and deprotonation. Okay, to form final product. Okay. Okay, so we stop here and then I will continue for the second type of rearrangement.